Now, in this video, we will discuss basic operational concepts. Now, activity in a computer is governed by an instruction. To perform a task, an appropriate program consisting of list of instructions is stored in the memory. Individual instructions are brought from the memory into the processor, which executes the specified operations. Now, this is the memory unit and this is the processor, which are connected by using the three different bus. Again, bus in detail I will explain in the next topic. Now consider it as a address bus, data bus, and control bus. Address bus, which is connected to the address register. MAR is nothing but a memory address register, and MDR is nothing but a memory data register. And this is the control unit. Already in the previous topic, I have explained control unit and ALU both together, we call it as a processor. I have explained. Not only these two registers, along with these two registers, many registers are there in the processor. Now we try to analyze all those. Now already I said that MAR is nothing but a memory address register. MDR is memory data register. These two are directly communicating with the memory, and control register is also communicating with the memory. These three are communicating with the memory directly. This is the address bus, this is the data bus, and this is the control bus. Now PC is a program counter which holds the PC is the program counter which holds the starting address of the starting address of the program. Now if this is the Now, if what is program? Program is set of instruction. Now, if you consider these lines are different types of instruction, now this is completely called as one program. And this program is stored in the memory. Through the keyboard, we are storing this into the memory. Now, program is stored into the memory means what? Each and every instruction is stored in a memory location. Always program counter holds the starting address of the program. It holds the starting address of the program. So now IR is the instruction register. Now here if you are writing a program is nothing but an instruction which is having opcode and operand. Opcode is nothing but a operation which is has to be done, and operand is nothing but on which data is supposed to perform the operation. So whenever it is uh, getting the opcode from the memory, that opcode is given to the IR, and operands are directly given to the either registers, general purpose registers, or into the ALU. Okay, now these are the general purpose registers. R0 to Rn minus 1 general purpose registers are there. Now with these registers we are using for doing the operations. Now generally if you write a high level language program, if you wanted to do the addition, you will write for example 2 plus 3 you will write. 2 is one operand, 3 is one operand, and plus doing addition. Addition is one opcode. So that is a command. You can directly give the operands, or you can assign these data to some variables. Now in this processor you can't assign those variables to assign the operands to the variables. Now you have to assign the operands to the register. By using the registers you can do the arithmetic and logical operations. So this is about the now control unit. Already we have discussed. It will give the control signals like read, write. Now whenever the processor want to read the data from the memory, this control unit give the read instruction. And whenever microprocessor want to write the data into the memory, control unit will give the write instruction. So, and also not only this read and write, and it will give it is having so many instructions. It will read the status of the each and every device, and so many other control instructions are also there, but most popular control instructions are read and write instructions, and ALU will do the arithmetic and logical operations. This is about the processor diagram. Now we will see if we give one instruction, what happens, how the instruction is performed. Now this is the one instruction. Now this is a program. This is a program is nothing but a set of instruction. If one instruction is add location comma r naught. Add location comma r naught is nothing but in this is a memory location. Instead of giving one a numerical address, we are representing the memory location with this LOCA. Okay. Now add is the operation. We are adding the content in this memory location with the content in this register. Now here you can see R naught is a general purpose register. In this register, whatever the data is there, that data we are adding with the location. Now, for example, LOCA is one more location which is not included in this program, one more location, separate location. In that location, whatever the data is there, that data we are adding into this R naught data. And again, result will be placed into the R naught. So with this instruction, the memory location data operand is not going to be changed, that is preserved as it is. But after this executing this instruction, after the execution of this instruction, R naught, whatever the previous data in the R naught register will be replaced by the result. It will be replaced by the result is nothing but what sum. Now the same instruction we can also write in this manner. Instead of adding the location directly with the register, now here what we are doing, load location with a R1 means nothing but whatever the memory location value operand is there, that operand we are loading into the R1 register. Now, instead of doing the addition of location value with the R0, now here we are using the R0 and R1, two registers we are using to do the addition operation. So for that, the location, memory location content we are moving into the R1 register, and this R1 register we are adding with the R0. Now, for example, in the location, two value is there. In the R1 register, three value. In the R0 register, three value is there. That two we are moving into the register R1. Now R1 consisting of 2 and R0 consisting of 3, and these two values we are adding by using the add instruction. Now whenever we give this instruction like this is called as a assembly level language program. When you give the assembly level language program by using the keyboard, and in the when you are giving writing the assembly level language program, assembler is there that will convert the assembly level language program into the machine language or binary language. If you are writing the high level language program, that will be converted into the machine level language program by using the compiler. But now if it is a assembly level language program, then assemblers will convert the assembly level language program into the machine level language program. Now instead of add, the in the memory, it will store the opcode. Opcode is nothing but operational code. What operation it has to be done. For add, there is a specific operation code. For subtraction, there is a specific operation code. Like that, each and every operation, there is a specific operation codes are there. After giving the instruction, that specific operation code will be loaded into the memory location. So whenever we execute this instruction, of example, if we are executing this instruction, what happens inside the processor, we will see. Now MAR, now first initially the PC holds the starting address of the memory location. So that address is placed on into the MAR, and that MAR, that address will point to the address location in the memory. And whatever the opcode is there, now add location comma R1 means what? Add instruction is nothing but opcode. Opcode will be placed onto the data bus, and it will be fed onto the MDR, memory data register. Now this opcode by loading the MDR with the opcode, processor will not understand what job it has to do. For that, again, that opcode will be loaded onto the IR, instruction register. This instruction register will decode the opcode, and after decoding, the processor understands that what job it has to do. Thereby, the control register gives a signal to the all the registers. Now, after placing the starting address, control register will send the read signal to the memory. Thereby, it will read the opcode onto the MDR, and MDR will place the opcode into the IR. IR will decode the instruction opcode, and the processor will understand, and thereby control register will. Now, for example, if the add location comma R1 is the instruction, then control register will send the signal to the ALU, and it will say the ALUs to ALU that you have to add the two operands, and also one of the operand is in R naught, so it will give the instruction to the R naught, and also one more operand is in the memory location. Thereby, again, that memory location will be placed onto the MAR. It will go to that particular location. Now, whatever the data is there, now this time it is not opcode, this time it is a operand. Operand again will be placed onto the data bus, and again onto the MDR. Now, whatever the data is in the MDR will be loaded to the ALU, and whatever the data in the R0 register, again that will be also loaded to the ALU. Two operands are loaded into the ALU. Now, ALU will do the addition operation. After the completing the operation process, again the result will be stored into the R0 register. Now, this is happens inside the processor. Now, if the processor is executing this program, this is one instruction which we have discussed, add location comma or not. If such instructions are, many instructions are there, if the complete program is being executing, in between, one after the other, the processor will execute the program. If in between, if any IO devices are requesting the processor for the services, then processor stop the executing this program, and wherever the processor is there, that location will be stored into that memory location or any register, specific register, and it will go to the that particular ISR. ISR is nothing but a interrupt service routine. When any IO devices are requesting the service, then that is called as a interrupt. Then it will stop executing the main program, and it will go and execute the ISR. ISR is nothing but again set of instructions which are meant for this specific device. Keyboard is an input device, printer is an output device, and if each and every device is having its own operation, depending upon the IO device's request, it will operate the particular ISR program. And after completing the ISR program, again it will come back to the main program where it left the execution, and it will start executing from that instruction. Now, this is called the interrupt and interrupt service routine. This is about the basic operational concepts.